So guys, next chapter is error. So which is an important chapter and an easy one as well. People generally don't talk of it, but this one, many questions are asked from it from in past. So which makes it an important one. So first of all, error. Error we know, if we are in physics, in sciences, we do experiments, we do measurements. So when measurement is there, so there would be chances of having errors, human error, and there would be some un you know unwanted chances, the causes which we cannot control. Okay, so different causes are there for error. Maybe human error, maybe there is a temperature, maybe there's pressure, there's a flow of the air which is causing the error. Say for example, you have done one experiment like that of pendulum, time period of a pendulum. Okay, so when we do this experiment, we takes not one reading, we takes many readings and then take average, because taking averages is like reducing errors, not exactly diminishing errors, but it reduces errors. So that is error. So I'll define them one by one, and basically we'll jump to the problems, what sort of the problems are asked in exams from errors. Okay, so let's come to the thing. And what is this thing called like as absolute error? First thing is absolute error. Absolute error, it's nothing but just the difference between the true value and the measured value. True value and the measure value. And by that we will learn many things about error. So let's start it. So for example, I did an experiment. Okay, I did an experiment and noted various readings. Say for example, the time period of pendulum experiment is, and the various readings are x1, so this will be measured value, x2, x3, like this n times. So if I want to know the true value, so that would be the mean. Okay, if I want to know the true value, so exactly we don't know the true value na. So what we do to get closer to the true value, we took the mean, which I am representing by just x, yellow x. So I took the mean of all the measured value up to xn. I took the mean, and that would be the true value. So this is the true value. Okay, so now let's come to the main thing. What is the absolute error? So I told you the absolute error is the difference between the true value and the measured value. Is the difference between the true value and the measured value. Okay, so true value is come as average, that is I represented with x. So if I talk of the absolute error, so it would be like true value is x minus measure value is x1. So absolute error delta x2, true value is x minus measure value x2. Thereby I would get the absolute error of every readings, true value x, x3, likewise for till xn, x minus xn. So these all in yellows represent the absolute error. Okay, now there is one more term, mean absolute error. And think yourself, what would be the mean absolute error? Just the mean of all the individual absolute error. If I'm talking about the mean absolute error, say for example, it represents with delta x, So just take the mean of all the absolute error. Okay, all the absolute error, just take their mean. That's it. So these are the things they ask. So conceptually you should need to know these things as they ask in exams. Just if just you know the definition and have a feeling of what is that, so you can crack that problem. Okay. So we call this as mean absolute error. Mean absolute excuse me, mean absolute error. So this is the point. Okay, so just the definition. So let's with that, there is another one technical term I should explain to you, that is a relative error. See, what is a relative error, you would ask? Relative or the fractional error. Relative or fractional error. Relative or fractional error. So it is actually the ratio of mean absolute error and the true value. It is the ratio of both mean absolute error, mean absolute error ratio, and the mean value. True value is actually the mean value. So mean absolute error and the absolute error and the mean value ratio is the relative error. Okay, I hope this is absolute actually. Okay, so that is all about the basics things, technical things regarding the errors. Now let's come to the main point, which is ask in the exams. The questions I will go to the application part rather than discussing all the things. So application part here comes, what are the propagation of error? How do you know questions in errors? What type of questions comes in error? So first of all, propagation of errors in which I give you the various operations like addition and subtraction. How do you carry out with the addition, subtraction, and addition? Now I'll show you how do we write a reading in physics. So if I say the time period of a pendulum, I did an experiment and the time period comes like this way, 2 minute plus minus 0.004 minute. Okay, so this part plus minus 0.04 is actually the error. This is the reading, this is the measured value, and this is the this is the true value, mean value, and this is the error. Okay, that means the time can go this much up above the measure value, and this can go the real time 0.04 below the measure value. So this represents the error. The way of representing error in experiments or readings is like this only. So if I say there are two readings, say for example one reading is like 2 plus minus 0.2, and another reading is, say for example this is A and B is 3 plus minus 0.03. So if I say, what would be a plus b? What would be a plus b? It would be 5 plus minus 0.2. It would be 5 plus minus 0.3. It would be 5 plus minus 0.5, or it would be 5 plus minus 0.1. So if this is the problem, so how would you actually add error as well with the readings? So the answer of this is simply this one. I'll give you the basic funda. Whenever you add readings, errors or subtract readings, error are always going to add. You just need to add this error part. This error part, in case of addition subtraction, you just need to get add. You just think yourself, no? The maximum value of this can go 0, 2.2, and maximum value of this go 3.3. So even you are adding the maximum value, you would get 0.5 up above the measure value, 0.5 above the, and even you subtract the minimum value of them, you would go 0.5 below the measure value. So that is the case over here. So just add and subtract the errors. Okay, so we'll move ahead. Error is this, and even in case of subtraction, you can easily do. You just need to plus error all the time. You just need to add error, no subtraction. You just need to add error. You must be thinking, oh, now I need to subtract. If it is subtraction, okay, I give you in general form, generic form. So if one reading is this and other reading is reading 1, reading 2, so even reading 1 minus reading 2, or reading plus minus reading 2, so it would be a plus b plus minus delta a1 plus delta b1. Even, r1 minus r2 reading difference would be a minus b plus minus delta a1 plus delta b1. So they are adding, I'm adding them. Okay, in case of subtraction as well, in case of addition as well, errors are always going to add. You are going to always add errors. Okay, now the process which is important is multiplication and division. When you have readings and the operation is either multiplication or division, both are same. So what we do with the error, how we need to proceed in that case. So for that matter, let's come to the problem. Say I say x is the product of a and b, like length into breadth, something like that. Okay, again for a, the error is a is represented as this and b is represented as like with this error. Then what would be, x, delta x, if you say, so would it be the product of this, which is very wrong, or is there a sum of this, which is again very wrong, or it would be the difference of this, which is again wrong, or it would be the division of this, which is again wrong. So you must be wondering, everything is wrong, then what is right? Okay, so you can see that every operation here is almost wrong. So you must be thinking, your first action would be, then what should we do in that case? So I'll tell you and teach you the very thing we need to do. Okay, let's discuss it.